let's go ahead and we are going to move into our engineering tribute. So this is a segment of the show where we get to highlight some of the cool engineers that have made a significant contribution to research or society as a whole. And today we're taking a look at Phil Nuytten, who is kind of a local legend here in Vancouver, North Vancouver. He has worked on a number of different projects related to the deep sea and space, so actually the extremes of nature. So let's go ahead and take a look at Phil Nuytten. So first things first, Phil is the inventor of the NITE suit. So this was actually developed for deep sea exploration, and the NITE suit was built to allow for deep divers to have better grasp of things when they were underwater. So we can see there's actually a jetpack on the back that pushes you forward and backward. And there's a whole bunch of joints, okay, rotational bearings that allow you to have a pretty full range of movement in this suit, even though it's all hard, sealed, and enclosed. And then those little grippers on the end can be swapped out for different kinds of tools. So it's pretty cool, and I really like that on the suits there's that big loop on the top, the big hook, right? So sometimes, you know, when you're deep sea diving, you want to be attached to something, you know, hooked up so that you can actually be pulled back. So that's what they've done here. They put a little hook on there, not just for moving it around maybe and transporting it into the water, but maybe you could even leave it on. I don't know. Maybe that's dangerous, maybe not. But very cool. He's also the inventor of the exosuit. So this is actually a suit that was designed for the Canadian National Defence to help with submarine escape. So if you're in a submarine and you're worried that it might be going down, you can jump into the exosuit and escape the submarine. So it's pretty cool. We can see some important aspects of the actual exosuit here. So we can see that it's made of an aluminum alloy. Now aluminum is one of the lighter metals, and that makes sense that you would want to have something fairly light, because it means that you can move around in it a lot faster, right? And that comes from, you know, Newton's equations, right? F equals ma. So the more mass, the heavier that suit is, right? The slower it's going to be to get it up to a specific speed, or the more force it's going to take, right? You're going to have to work a lot harder to move that thing around. So having a light suit is important. You can see that there's some powerful LED lights, right? And that's really important for when you're underwater. There's not a whole lot of light, so we need to illuminate it. We need to have some really heavy-duty lights on there. Of course, there's those rotary joints, right, that allowed for those full ranges of movement. And yeah, those cool foot pads, I like those at the bottom. Those look pretty cool. Yeah, so there's a lot of really cool aspects that went into this design of the exosuit. So a little bit more about Phil Nuytten himself. He is a Métis and likes carving a number of very cool pieces of artwork. He is a big lover of music. He's got a large collection of original music from around the world from various artists. And he is an avid swimmer. Phil, loves to swim, deep sea and deep sea dive. A cool side story is I actually, when I was a lot younger, I did a project dedicated to Phil Nuytten because we were looking for local heroes. And there's a bridge here in North Vancouver called the Ironworkers Bridge, or Second Narrows. And it's called the Ironworkers Bridge because when it was originally being constructed, it actually collapsed. And there was a number of workers that were working on the bridge when it collapsed. And Phil was fairly young at the time, working on a tugboat, and he actually dove into the water and pulled these people out and saved a bunch of them, which inspired him to later go on into engineering these deep sea suits. So that's pretty cool. So he's a hero of mine as well. So that covers our engineering tribute. Let's go ahead now and move into our maker highlights. So this is a segment of the show where we get to highlight a couple of the cool projects that students have been working on here at ZenMaker Lab or submitted to us by makers from around the world. And today we're taking a look at two projects in particular, Liam and Dylan's. So let's take a look at these two fantastic projects. So first up, we have Liam's FLOORBALL stick. And this was actually designed based off of the design of a FLOORBALL stick, which is included in our pod program pack. So if you've heard about that, we've got of course our pod program here at ZenMaker Lab, where we get to learn about various design aspects of design, make, and play. And Liam here has actually redesigned the FLOORBALL stick here. So that's pretty cool. So we can see that it's got a mesh in the what would you call that? The paddle, I guess, on the bottom, or the stick at the bottom of the stick. But he's got included the mesh down there, which is good. We've also got a handle, and of course we've got a rod to connect the two. So I thought this was kind of cool that we're trying to rebuild something that we saw in real life. And there is a lot more detail that Liam can add with some of the time that he has on this project. So one thing could be adding a little bit of a curve to this stick. So a lot of the FLOORBALL sticks are actually a little bit curved. Something else is there's some labeling and stuff that's on the rod, so maybe we could add that. And I think that the rod actually kind of changes. It's not uniform all the way down. It goes from sort of thicker to thinner. So that could be something that we could add to. I also noticed that the handle is a little bit off, so maybe we want to center that properly. But other than that, yeah, this is a really cool design. I really liked it. I can also see here that there are some parts that are kind of disconnected, so maybe we'd want to move those hole type blocks around. But fantastic job, Liam. I really thought this was pretty cool, trying to recreate something from real life. And actually, this has been some advice that a lot of artists have used when they are designing things. Is, you know, we steal from nature, we steal from the things that we see, and we repurpose them into a different medium. We put our own spin on them, right? So yeah, I thought this was kind of cool that we are mimicking real life, right? Because that is giving us some insights when we work on our own projects and our own designs. So for example, you know, Leonardo da Vinci used to just watch like birds in the grass and clouds, and he would try and sketch them as accurately as possible. And there's a large amount of like math and detail that he had to consider when he was drawing like all the curls of somebody's hair, right? And trying to really simulate like the transparency of cloth with paints. So pretty cool stuff. So next up, we are going to take a look at our next maker highlight, and that is Dylan's Celestial Gary. So why is this called the Celestial Gary? Well, actually all octopuses here at ZenMaker Lab are a special species of octopus. They are the Gary species. And so Dylan has put his own twist on the Gary octopus. He has created a Celestial Gary octopus. So let's take a look at this octopus. And this was actually very well done. Just looking at the chains, I can see that the chains were well done there. Good connections. So let's go ahead, let's take a look at a few things here. So first things first, I can see that there are some stars that have been embedded into Celestial Gary's head here, which is very cool. Very cool. Let's pull this thing apart a little bit more so I can actually duplicate this and kind of pull him off to the side, and we can focus on this one. So one thing is that the chains all look to be connected properly. And even though these rings aren't necessarily touching at the bottom, that's not the end of the world. We can actually pull this thing apart and get a better look, a closer look at some of the different parts here. So I'm just gonna break this apart a little bit. There we go. So here we're using the duplication tool to actually duplicate this piece all the way around, which is good. And if we take a look here, if I make this a holotype, we should be able to see that the rings are not touching inside these blocks, which it looks like they're not. So that's fantastic. And it looks like there's enough room on either side. So why did I make this a hole type? What am I doing, you might ask? Well, we're actually looking to make sure that the ring is passing through that hole. And it looks like Dylan made sure that that's true. And he also gave enough space here for the torus and the block. So really good job, Dylan. A lot of students make that mistake when they're making these interconnected parts. So that covers our maker highlights. I hope that you enjoyed. Don't go anywhere, because up next we have our special guest, who is Andy Goliath, who is an artist. So stay tuned.